Hi, everyone. My name is Texin. I'm an internationalization consultant and also working with Translation Commons. Try to remember translationcommons.org because we're an entirely volunteer-based organization and we're welcome. You should go to our website and take a look at what we do. We're working for Indigenous languages. We provide guidelines, keyboards, help Indigenous language communities to digitize their language so they can be online. And so that's me. I've been doing internationalization for 3 decades. It's a long time. I'd also like to introduce my 2 colleagues. Tabea de Wille is an associate professor at the University of Limerick. And her student, Adesh Maharaj, is a graduate student, has also been participating. You're going to hear from him shortly on this project. He's a master's student, recently graduated, now working on his PhD at the University of Limerick. And I'll tell you a little bit more about Translation Commons and our work with the University of Limerick. With this, there we go. Actually, it's a funny thing. It was about 3 years ago, the first UTW. We were talking about keyboards, and I was asking, why aren't we using AI to generate keyboards? And at the time, everyone says, yeah, we should, but then not that much happened with it. Also around that time, 3 or 4 years ago, maybe, you can correct me if I'm wrong, Jeanette. Translation Commons created a keyboard working group where we were developing keyboards with Craig Cornelius and several other volunteers, and we've been producing keyboards for Indigenous language communities since then. Tabea is also a member of the keyboard working group, and we've been working with the University of Limerick. In fact, one of the things that we did is we created a workshop for keyboard development, and I went over to Limerick and we delivered a workshop there. We enticed nine or so students to have an interest and participate. And Tabea has taken that program and generated a lot of interest in students and continued the program. And one of the outgrowths of that is this AI keyboard generation project. So that's been great. Translation Commons partners with a number of groups and communities. I'm not going to spend more time on that, but because I want to get into the generation of keyboards. And so the motivation, you've heard this in several talks already, is there are a number of Indigenous languages that are not served by digitization. And people keep throwing the 3,000 languages number around that are endangered. You can hear other statistics. People question that number. I've heard a number of 8,500 of the instead of 7,000 languages. The numbers vary. The point is there's still thousands of languages without being able to use digital systems. Not only that, some languages are supported, but they have incomplete support and or some type of partial support. I worked on a keyboard for the Dogon language, which had a keyboard, but it didn't support tone marks, which they wanted to use to be more accurate and also for educational purposes. They wanted to be able to enter those. There are also a number of existing keyboards that for one reason or another aren't really suitable for the language they claim to support. Can be very inconvenient to type. Please come on in. Come on in. The key placements can be hard, maybe missing some characters. May also require a regional or dialectic variant. And also spelling rules affect how you use a keyboard, and also if it has autocomplete or some other features like that for selecting strings that may need to vary according to the specifics of the language. And also users have different preferences, not only personal preferences, right? We say, well, I really wish it was another way, but because they use the keyboard for different applications. There may be a native application that makes use of certain characters in a certain way, which are awkward for a keyboard, but are perfectly fine for another application to use that keyboard. 100 years ago, I worked for a spreadsheet company, and you know the @ sign is used in a lot of formulas on spreadsheets. And in some of the countries that we wanted the product to be used, the @ sign required this awkward multi-finger, stretch your hand all over the keyboard in order to type it. Yet it was one of the most frequently used character for that application. So there are a number of reasons why you want to be able to modify keyboards and generate them and support indigenous languages as well as for other reasons. So what's the solution? Well, of course, we want to automate the generation of keyboards. And the advantage of automation is, of course, you can have lots of options, right? You can say, well, I want a keyboard according to a certain set of formulas or metrics, but maybe I want to have some different choices. And with automation, if you can generate them quickly, you can generate them cheaply, and maybe you can customize them in different ways. So you get quicker turnaround, which is really important. You also reduce the requirement to have a specialist who knows about how to develop a keyboard, right? If we can raise the level up and say, here's some text input. I want you to generate a keyboard that looks like this, make these changes, and come up with another one. Then you put Craig and myself and some other people out of business who are working one-on-one with a community over several months to develop a keyboard. So we can then scale up, right? If we really want to support those thousands of endangered languages, we can't do it one language at a time. Not only because of the development work, but it takes time to go back and forth to a community and try to understand the requirements from their perspective and how they're using the keyboards. So in this way, we can also, if we can generate variations, we can give communities choices, right? So right now, as I mentioned, we go one-on-one with them for, here's a keyboard, tell us what you would like to change. But if we could give them several and say, which one is better? And help us understand why it's better, because then we can continue to make improvements, then that's a much better and a much quicker process. It also gives communities more control over the definition of the keyboards. The other thing is, in going through this process, we can collect data on how people are using the keyboards and their choices. And we can use this to help us improve the process, not only for that keyboard, but for other keyboards going forward, because we start to learn principles and designs that work better for people and why, right? Any questions? I don't mind being interrupted. Okay, so here's our idea. A good portion of this comes from Tabea. We automate the generation of keyboards. We take those keyboards, which we're going to talk about, that's the meat of this presentation, but we could also have a platform where a community can view the keyboard or a number of variations, and they can use it for testing, they can use it for discussion, there can be a part of that platform, essentially a community discussion space where the community evaluates the keyboard, but also the developers are participating and learning what they need. We can also provide some information on design, why we do things a certain way or why things have to be a certain way. And there's an opportunity for prompting, which is where somebody can, through AI, say, I like this keyboard, but can you change it in this way? Move these characters around. Switch them from these keys to these keys and get improvement that way. and using prompt input. And the result goes back to the AI generation. We generate the variance, and it comes back again for more evaluation. Isn't that brilliant? It seems obvious once you see it, but we haven't had this, right? We've been going, I'll create a keyboard, I'll send it to a few of the activists or advocates for a community. Maybe they get some community involvement. And then months later, we get feedback. That's the way it has been working. So our group has 3 projects that we're working on. One is not just Translation Commons. We're working with the CLDR Keyboard Working Group to create a guideline for principles of keyboard development. What should go into it? And as you can imagine, there's some things like finger metrics and performance there, but those of you who know about Dvorak keyboards, you know that's not the only thing, right? And some of it has to do with legacy of what communities are used to or what the majority language in a country uses in order to be able to leverage those things. There are many principles and not obvious choices that go into that. So one of the things we'd like to do is collect the reference materials that exist today, which are sparse and not all that deep, and work with CLDR and some of the experts in the Translation Commons group and University of Limerick internships to have also students participate and create this guideline. The other project would be the community platform that I mentioned that will be worked on by University of Limerick students. And then we have the project I'm going to talk about today, which is keyboard generation and prompting. It was largely implemented by a student, Adesh Maharaj. Just so you realize, I think this project started out as a comparison of which AI do we want to use? Do we want to use a genetic algorithm, which I'll talk about in a minute, or do we want to use an LLM? And as they went through the comparison, they realized, you'll hear a little bit about the benefits and pros and cons of each, but what they realized was you could combine them. And that's where the platform idea became evolved, because the genetic algorithm was very efficient and automatic, but the LLM system allowed prompting and customization. And so being able to use the two together enabled a hybrid approach, which is going to be even better. And because I know there's a couple of experts, at least a few experts on keyboards in the room, these are baby steps. You can ask all sorts of questions about why didn't you do this? Why didn't you do that? We simplified what we were trying to do to prove the concept that we could generate using these AI algorithms, generate keyboards. We focus mostly on some simplified metrics for hand performance and the like. We know that we have to add some other things. We also kept it to just a few languages to begin with. So before you start asking about, what about Arabic or some of the other languages, we'll get to those things. Okay? So, and the briefest overview before we get into details, we start with a corpus of data. And we use that in order to analyze what are the characters that are in that corpus. Can be multilingual, but what are the characters? Yes?
How big a corpus?
I don't remember. It's not huge because this is proof of concept, right? So there's a few thousand. I'm going to punt on that. It really doesn't matter because this is more conceptual. But if you want, it's unfortunate Adesh and Tabea couldn't participate. They're in Ireland, of course. But any of those questions, if you're really interested, we can post them. Or maybe Jeanette, you can ping them. So we start with the corpus. We figure out the characters that are involved. We get frequencies of usage. We also get frequencies for bigrams. We get some other data. And this helps us establish the initial weights of how the characters should be associated on the keyboards. And we input that into a genetic algorithm. Genetic algorithm, think in terms of evolution, survival of the fittest. We generate from seeds, a whole bunch of different choices, maybe 1,000 different choices. And it runs through using performance metrics of the generated keyboard and says which ones are good and which ones are not good. And it kills the ones that are not so good. And then it runs again with some other variants, trying to improve the ones that were good to make them better. So we might start out with 1,000, and then we end up maybe the 3 or 5 best ones that get generated. How long do you think that takes? He says an hour, 15 minutes, 8 minutes. Comes up with 3 keyboards that are probably pretty good. We can take those keyboards and we use a large language model where then a user can say, I'm working with this keyboard. I can visualize it or I can play with it. And it says, make a change. I'd like it to be a little bit different. And with that input, we generate another keyboard or multiple changes to keyboards, which can then be input again to the genetic algorithms. Generate some more variants and see if it can't be optimized further. That's the whole process. And the benefit of this is you're getting a mix of automatic generation and human input in order to make the best choices. And some of the kinds of things people put into the prompt, you might see, for example, punctuation is very frequent in a document. And you don't want those on the home keys. So we might put in some information, move the punctuation down below or move this punctuation to another layer. And actually, most of that is we generally already take into account the genetic algorithm and some of the underlying code because we know we don't want punctuation on the home key. Yes. Well, so the question is for low resource languages, how much data do you really need? And just for keyboard layout or initial keyboard generation, maybe not that much. But we also have the opportunity for users to add more, and also they can start using keyboards right away and add more to the data. So at some point, the corpus doesn't become, it's not like you're doing grammar correction or things like that. You just need enough to know what the right characters are that are being used. So. Okay, so with that, I would like to invite you all to listen to Adesh, who's going to talk in a little bit more detail. Everyone here okay? And boom, boom, boom. I don't know why this is so slow, but that's pretty much our presentation. You can see where we're going with this. It's a work in progress. And I'll mention again, Translation Commons is completely volunteer oriented. So we'd love to have more people contribute to the keyboard project or to some of our other work. So I'll try to answer questions. Yeah, I don't think it came close to Dvorak, but really we didn't compare it with that. It was so yeah, I don't know. I don't have a number for that. I could ask him to do that. It might be of interest. So
is this intended to create keyboards for languages that don't yet have a keyboard layout? Or are you just looking for the ergonomic gain?
no, the focus, so the question was, is this intended for Indigenous languages or just to focus on the performance metrics? No, the metrics for performance were really just to have a starting point. We need to add more information about working with legacy keyboards and other kinds of design principles in here. But you have to start with something, and those metrics were easy to calculate, and other groups had already established, like the Carpal-X metric and some other metrics. And so we could calculate finger strength, finger frequency use and strain and those kinds of things. And going forward, we would want to add quite a few other metrics, including the calculation across layers and things like that. And yes, we're targeted for Indigenous languages. That's where we'd like to be able to help endangered languages going forward, but this seems to also be more generally applicable. But it's also hard if you have an existing keyboard and it's kind of adequate. That Dvorak, it didn't get picked up because it was more efficient. It just didn't get picked up even though it was more efficient. So we're not trying to change what people are using, although there are all sorts of keyboards on the market that deal with carpal tunnel and other kinds of issues. And so if people want to play with different layouts and also improve devices for it, they can. So also the technology is changing all the time. We have mobile phones and iPads and devices of different sizes. So there's an opportunity here to also improve as new devices come out in different size forms and the like, to also help with that. So it's not just taking QWERTY and expanding it when there's opportunities to do other things. But I'd welcome ideas for how else to use this or where else it applies. Greg?
Thank you. Will this genetic model or genetic algorithm be able to do things like have a combined characters like a umlaut versus a and a separate umlaut key?
What was the last part of that?
There are two ways of typing characters with critics.
Yeah, so which you can influence it as to which, the question was about you have composite characters or decomposed characters, right? So you can influence it to choose one or the other. So
because that's going to be really important, because the number of keys needed for composed characters may overwhelm its utility to have them pre-composed, especially when you get to lowercase and uppercase.
Yes. So one is the physical space for the keys and what you want to represent on the keycap, but that's also separate, or can be separate, from what you output, which is what I thought you were asking. You can influence whether it generates the composed character or combining characters.
So related to that, in the initial analysis of a corpus, looking to see what's the character repertoire, in a sense, that's a vocabulary of elements, right? That's a point where it seems like there's a question of, is it recognizing each combination, and, you know, an accent and vowel, for instance, as one unit or as a combination of units? And that could also be influenced by, is the data that's being analyzed in which Unicode normalization form?
Yes.
Composed or decomposed?
Well, as Adesh mentioned, he did some, when he processed the corpus, he lowercased everything and applied some other tactics to it. So we can do the same thing. We can put it into a normalization form if we want the keyboard to have a preferred normalization before we process it. So, or we can simply post-process and put it in the normalization form we prefer. Okay. Okay. Also, Andrew in the back has a question.
Is there any research on how easy it is for people to change how they use a keyboard? In other words, I flip between English and French. It takes effort.
Oh, that kind of a change.
Yes.
Um,
To learn a new keyboard layout. How tricky is that?
so not a language change, but just a change in the keyboard.
Yes.
It's funny, a long time ago, I saw some studies, but I don't recall the data. It wasn't even studies, it was YouTube videos of people who were looking at learning curves for moving to different keyboards. If you search for that, you probably come up with the same videos, or if you ping me, I can try and find it. Andrew.
Anecdotally on that topic, we enable the same keyboard layout for Danish and English in Denmark by request from our representatives in Denmark. This is for Microsoft. The reason for that is to avoid any sort of discontinuity between the keyboard layouts. And so it's easier to type on the same layout using different languages and to have the language switch without the keyboard switching, provided, of course, both layouts support the same set of, the same orthography. So my question was, no, I forgot my question. Well, two things. Tomorrow we'll do a deep dive on LDML and where we're at. I loved the comment that LDML is used as the basis for across the industry. That's where we'd like to be. I'll give you an update on where we will be tomorrow, but thanks for the plug. Coming back to my question, over the summer, we also looked with the Silicon interns at the question of how do you seed keyboard layouts for language communities that didn't necessarily have one. And so a factor, it was a different approach, different merits and different approaches is great. One of the factors that we looked at was, is there a keyboard in that community already?
Yes.
Such as in North Africa, there is an Azerty keyboard that's present. And how does that influence what keyboard we might generate for a language which was going to extend or build upon something that was in the environment? So the Latin layout portion was worked on so that we could try to extend a Latin layout in a community with additional signs that were to supplement the orthography of the new language. But the other piece of this, which was sort of future work, it was to say, if we were going to add say a Tiffany keyboard, we have one, but if we were going to add a Tiffany phonetic keyboard, how would that look if you were going to do it in a community where there was Azerty or where there was Querts or QWERTY? And so could you capitalize on phonetic associations that were already with that user?
So it's a complex choice, right? You have people have some history where they learn certain systems, they learn a keyboard for the majority language in a region, maybe. And maybe there's more than one, depending on the region and what their choices are. You may also want to favor what's become available as opposed to what was historically available, because that also changes. And then you also have some linguistic issues where even though the characters are the same, the frequency usage may be, or the way they're used may be completely different. And so the argument to keep the same keyboard because you know where the characters are, but it's wickedly hard to type because it's not the way you use it, comes into play. And then you may also have some communities that say, actually would like to emphasize our education, our cultural preference, and do our own thing and not necessarily build on what's there, even though it might be expedient, right? So you get all sorts of factors. I think the nice thing about having the LLM approach is you can go and say, here's what I think I want to do, right? I can say, I want to take a Xerte and modify it, or I can take something completely different and say, start from here, and then help me improve it, whether it's performance metrics or other metrics, or simply to work with the community and say, one part of the community says, we use this app and we need these characters to be over here. So we have some flexibility. We don't have to say, pick one or pick the other. But that's where the design document that you and I and others are going to be working on might point out, here are some of the trade-offs. So, but welcome opinions and other ideas on how best to work it. So working in a cultural space, you have to be flexible. Sure. Hold it.
Do you happen to have the example of the prompt that the student used?
Oh, he might have it in his slide. Might be one of the things we took out of the slides for, let me see. Where is it? Yeah, no, I don't have it in this deck, so sorry. But it's English language. It's take this key, keep it on the home row or swap A and Z. It's that kind of a prompt. What would you expect or what would you like to see?
I'm just curious.
Yeah,
I think that is important, right?
Right. So you want it to be something that people can use. We don't want it to be technical where you have to say, all right, change this JSON statement to this, right? So, but that's the benefit of LLM. We can get it to do that easily. It's kind of designed around that.
I'll ask a question. It sounds like, if I understood right, that the LLM was primarily being used to facilitate natural language editing.
Yes.
As opposed to using the LLM as part of the generation and evaluation algorithms.
Yeah, we found that the genetic algorithm was much more efficient, generated lots of versions, and came up, depending on your metrics, came up with the most improved and useful, the fittest versions, right? And then you wanted to have some human preference to be able to input in there because the algorithms don't always do the best from a human perspective.
So in that sense, limitation of training resources for the LLM isn't the same thing as training for the genetic model, right? And so if you can have the users get by with their editing interaction being in English or French or Spanish, something that is better supported in the LLM, maybe that's okay for that experience because that's not something you're asking every part of the community to use. You're just something that a handful of designers are doing. But you will still want some corpus of data that your genetic algorithm is using to train.
And I wouldn't completely dismiss that the LLM isn't using some metrics and generating some it's generating keyboards, may not be just editing. You can borrow from the fitness metrics and some of the stuff that you're using in the genetic algorithm. But yes, fundamentally, you don't have to train the LLM in the same way. So.
Hello, my name is Ali. I am creating iOS and Android keyboards for 11 years. Also, last 2 years was practicing using LLMs like you to create convenient keyboards, mostly for Cyrillic keyboards.
For which keyboards?
Cyrillic.
Cyrillic.
Yeah,
Okay.
it's about for 120 languages. So my question is like, English keyboard is like really universal Latin keyboard, right? When you tap on the T or O, you will see out of the English Latin letters. Yeah. Did you created something like for other scripting? For example, I was creating universal Cyrillic keyboard. Like when I tap on O, I will see O, like Kazakh or Tatar languages. Yeah. And to me, it was completely hard to generate because it don't, for example, ChatGPT don't realize the differences between different types of O alternative.
Right.
Yeah. How did you overcome or did you see such problems?
Well, not for because we were just using the 3 or so languages that were mentioned here, right, which were Latin based. But when we develop keyboards manually, right, we take it when you have multiple versions of a character, we use menu options or other options to generate choices or move them onto different layers. So there are solutions for that, but from the LLM approach, we haven't gotten to that level where we have to deal with the multiple accented variants across multiple layers. But would be happy to work with you on that.
Yeah.
So just to let people know, the next sessions are going to be starting up in a moment in the other rooms. There isn't another one here. So if people want to continue asking text questions,
I'll hang
feel
around
free
for
to
a
hang
little
around
bit.
in this room.
Thank you, everyone. Appreciate your attention.